What we've talked about is how to factor trinomials. So you can now factor anything with 3 terms. We've talked about factoring by grouping, so you can factor things with 4 terms. But what we're going to talk about in 5.3 is some special factoring. Two of the 3 things we talked about in this section will involve things with 2 terms. And there are some things with 2 terms that we can factor. So that's where we're going to start. Do me this favor, gives us the opportunity to practice this. I want you to multiply these 2 things together, FOIL this one. Okay, so let's say we have x plus 9 times x minus 9. Multiply those 2 things together, and then we're going to look at the result. All right, first outers, inners, lasts. Here we go. My firsts are x times x, or x squared. My outers are x times -9, or -9x. The inners are 9 times x, so plus 9x. And my lasts, 9 times -9 is -81. The reason I want you to go through this, because remember, factoring is just unfoiling. We're going to start with the end result here. We want to work our way up into this. Okay, so when we factor, this is the end. What happens with my outers and inners in this particular problem? Yeah, you get 0. Okay, these 2 things right here, when I add them up, -9x plus 9x, those 2 things cancel. And the reason that happened is because the plus 9 and the -9, they're opposite signs. So what I have here at the end is x squared. These become 0 minus 81. Well, you're going to encounter this a lot. This is one of the more popular things in math and algebra as you approach. When you get into the next class, college algebra, we talk about the graphs of things like this, what they look like. So you're going to see a bunch of things like this. This is called the difference of squares. Doesn't look like I spelled that right, but I'm going to go with it. It's a difference of squares. The reason it's called that, the words are important. Okay, I don't want you to accidentally make a mistake with something that looks like a difference of squares. It's not. First, the word difference. What does the word difference mean? Subtraction, right? So this has to be a subtraction sign. Okay, for it to be a difference of squares. If this is a plus sign, doesn't work. Okay, what we're going to talk about. And then squares. Things that are squares are the same factor times itself. So x squared is x times x. 81 is 9 times 9. If both of these things are not a perfect square, then you can't do it. So again, the words have meaning. So before we go and factoring a difference of squares, I think you're going to be like, this is great. I would love to do this all year. Before we factor it, though, I just want to make sure we can identify. So here we go. I'm going to ask you this question. Is this a difference of squares? So the answer is going to be a yes or no to each of these. So here's the first one. Don't shout it out. Write it down. I want you to make your hypothesis, and then we'll talk about why it is or why it is not a difference of squares. So here we go. The first one, x squared plus 25. So write it down. 15 seconds. Make your hypothesis. Yes or no, is it a difference of squares? Is this a difference of squares? Yes or no? Okay. I will agree with you on half of it. These are both perfect squares. X squared is x times x. 25 is 5 times 5. Here's the key question. Is it a difference? So the answer to this one is no, because of the plus sign. So if you're given two things with a plus sign in between, it is not a difference of squares. You cannot factor that. Here's the next one. Yes or no? Is this a difference of squares? 4x squared minus 25. Write it down. Make your hypothesis. Yes or no? Is it a difference of squares? All right, what's your hypothesis? What do you conjecture here? Yes, it's a difference. That's good. It's a subtraction. And then are each of these numbers and things a perfect square? Well, 4 is what times itself? 2 times 2. X squared is x times x. And 25 is 5 times 5. So this is a big yes. That is a difference of squares. One more example. If you got a question, hit me with it. Would love to hear your questions. So here's the last one. Y squared minus 34. Is that a difference of squares? Yes or no? Write it down. Make your hypothesis. We'll talk about why it is or isn't. All right, yes or no? Is this one a difference of squares?
No.
Why not?
The y goes into it, but not a 34.
Perfect. Well said. It's a difference. The y is a perfect square, y times y, but 34. 34 is not a perfect square. There's no same exact whole number times itself. That gives me 34. Okay, so it's 17 times 2, but that doesn't do me any good. So because of this number not being a perfect square, the answer is no. Yes? If it was negative x squared plus 25. So this is a fantastic question. I've never been asked this before. I love it. So here's the question. If I have negative x squared plus 25, yeah, let me just do a quick little rearranging and we'll see why it is a difference of squares. This is perfect. So we can take these terms, we can put them in any order. So I'm just going to take the positive 25 and put it first. The negative x squared, put it second. And yes, now it's a difference of squares. So yes, that is a great question. So if there is a negative here and a positive here, it would still meet the criteria that we need. Once you've identified that something is a difference of squares, 4x squared minus 25, we're just going to follow the pattern from the multiplication problem I gave you a minute ago. And here's what you do. Once you identify this is a difference of squares, woohoo, it's a difference. Both terms are perfect squares. Here's what you do. It's going to be nice and quick and clean. 4x squared is what times itself? 2x and 2x. 2 times 2 is 4. X times x is x squared. 25 is what times itself? 5 and 5. And then you make one positive, you make one negative, so that when you FOIL it, the outers and inners would cancel. You're done. Once you have identified something as a difference of squares, it takes seconds to go ahead and factor it. So here's one for you. I've got several examples of this just to make sure we're comfortable identifying and factoring. So x squared minus 100. X squared minus 100. X squared minus 100 is indeed a difference of squares. It's a subtraction, so it's a difference. 100 is 10 times 10, so here we go. My firsts, x squared, break down to x times x. 100, my lasts, 10 times 10. and then you make one of them positive, one of them negative. It doesn't matter what order. So if you put the negative here and the positive here, absolutely does not matter at all. Done. Question about factoring a difference of squares. Yeah. No, it would not be this is kind of the corollary to the previous question that you asked. So if you did not hear, the question was, if I put a negative here, well, now it's not a difference of squares, because to get a negative x squared, you'd have to have two different things. So this first term is no longer a perfect square. Okay, so you can only have one negative for it to meet the structure that we need it to have. Okay, so great question. I love that you're thinking about and processing this. Here's another one. Try this. 64y squared minus 1. $64y squared minus 1. Well, 64y squared is what times itself? 8y times 8y, that is indeed true. 1 is what times itself? 1 and 1, and then 1 negative, 1 positive. It does not matter the order. So you should have 8y minus 1, 8y plus 1. Those are the two things that you are looking at. I've got 3 more examples. Each of them have a particular purpose for us. So the next one is this one, 81x squared minus 49y squared. $81x squared is what times itself? 9x, 9x, 49y squared. 7y and 7y, and then yes, make one of them negative, one of them positive, so that when you FOIL it, the outers and inners will cancel. Okay, 2 more. This one, this is my favorite problem to put on the test. So yes, I just spoiled the surprise. A week from now, when you take the test on factoring, there will be a problem super similar to this. Okay, so x to the 4th minus 16. I want you to just give it your best shot. If you can get it, that's awesome. If you can't, we're here, we're learning. Okay, so don't beat yourself up over it. All right, let's give it a try. There's 2 things I want to point out to you about this problem. So, first thing, what would you propose are the two factors for x to the fourth?
X squared.
Okay, that's great. X squared, X squared. Remember, we add the exponents. 2 plus 2 gives me 4. Okay, so if you didn't know that, that's okay. That's why we're doing this problem together. What are the two factors of 16? Okay, 4 and 4. And then I've got plus 1 minus the other, or minus and plus. So if you got there, you've done awesome. Here's the second thing I want to point out about this problem. Make sure you always factor completely. So notice, x squared plus 4. This is a sum. Okay, this is a plus sign. You can't do anything else with that. It's done forever. But this one right here, x squared minus 4. Is that a difference of squares? Yes. So this one ends up with another difference of squares. So the x squared plus 4, I'm done with. I'm just going to rewrite. It's part of my final answer. But remember, it has to be a minus sign in order to factor it. And since that isn't, we're done with it. Then the x squared minus 4. X squared is x and x. 4 is 2 times 2 plus 1 minus the other. So sometimes that happens with differences of squares depending on what number you're given. And I just think that's a fun problem. So just like that on the test. Okay, so you can know that going into it. Here's the last difference of squares problem, and then we're going to talk about the second of the 3 things involved in this section. And we'll probably put the third thing off until Wednesday. So here is the last difference of squares. I've got 5a squared minus 45b squared. But here's the problem. As you're writing it down, I'm sure you're thinking this, that neither of those numbers are squares. What's he talking about? Just like we talked the last problem of the previous section, the very last thing we talked about, before you give up on this problem, what do you notice about these two terms? They have something in common. Somebody said it. They have something in common. So that's what you need to do first, is factor out the common factor. And then what you have left will be a difference of squares, I promise. What's the factor that's in common to these two terms? Yep, well said. So 5a squared, when I factor the 5 out, I'm just left with a squared. And then negative 45 divided by 5 is negative 9. And then I've got that b squared. So I factored out the common factor. That is always your first step. Try to develop the habit of looking for that first. When we come back on Wednesday, just going to write out a quick little order or hierarchy of operations for factoring, and that'll be part of it. So this 5 is part of my final answer. Don't leave it off. And then the difference of squares. A squared is a times a. 9 is 3 times 3. B squared is b times b. Plus 1 minus the other, and we're done. There's my difference of squares. Before I move on, does anyone have a question, comment, or concern about differences of squares? We okay with them? All right, well, I hope so. I like to put those on the test, and I hope that you can just whip through those. Do me this favor. This is a trinomial. Just factor it. You know how to factor trinomials, it's just practice, but I have something I want to point out. So x squared plus 14x plus 49. All right, so this has a 1 in front of the x squared, so this is the simpler type of factoring where I only have to worry about my lasts. So the only choice I have for my x squared is x times x. And then what are the two factors of 49 that are going to add up to 14? 7. Yes, 7 and 7. So here's the thing to notice, okay? And this is my required expectation. If you get the same factor times itself, at the same factor times itself, what I would like you to do, please, this is a notational thing, I'd like you to write this as x plus 7 squared. So we factored this trinomial in the usual way, nothing different about that. We factored this, got x plus 7 times x plus 7. We noticed that's the same factor times itself, so we rewrite it as x plus 7 squared. This gets named something. I really don't care if you remember the name of it or not. I'm just letting you know so when you're doing problems in my math lab, you know what that problem's working on. This is called a trinomial because it started out as a trinomial square because it ends as a perfect square. Once you're done writing that down, do this one. X squared minus 12x plus 36. So x squared is x and x. The 36 is positive, but I need that up to negative, so my signs are both going to be negative. And what factors of 36 are going to add up to 12? 6 and 6, indeed. So once again, I notice, oh, cool, I've got the same thing times itself, so my answer is x minus 6 squared. Now, trinomial squares do have a particular structure. This is not required. Now, I'm going to show you a shortcut if something does happen to be a trinomial square. But you do not have to do this. You see something like this, you can factor it in the usual way of the trinomial. And like we learned at the beginning of this class, you could take the 4 times the 25 and get 100 and figure out the two factors of 100 that add up to 20, and that is perfectly golden. It will always work. But if you want a shortcut, this shortcut only works for trinomial squares. So this is a shortcut. Okay, here's the structure. You've got yourself a trinomial square. First thing, 4 is what times what? Okay, 2 times 2. 25 is what times what? So here's the test to see if it's a trinomial square. 2 times 5. 2 times 5 is equal to 10. When you multiply those two numbers, if you get a number that's half of the middle number, 20, you have a trinomial square. So 4 was 2 times 2, 25 was 5 times 5. So 2 times 5 gave me 10. 10 is half of the middle. So that, I'm just going to make a little note for you. Is this half the middle? If it is, you've got yourself a trinomial square. If it's not, you've got an imposter that you have to factor some other way. But here's the shortcut. If you take the time to do a few of these and remember that, if you identify something as a trinomial square, here's all you got to do now. You told me 4x squared was 2 times 2, so that first term is going to be 2x. You told me 25 was 5 times 5, so the last term is going to be 5. And I'm going to put a minus sign because it's a minus 20. And there you go. There's your trinomial square, which this is the same exact thing you'd get if you went through the whole process of factoring, which, by the way, is fine. If you do not want to remember shortcuts, if this kind of stuff, you don't remember it well, you don't have to remember it at all. Okay, you can factor this in the usual way and you will get this every time. So just because we do have this, if you want to practice it, I'm going to give you a couple of opportunities to practice the shortcut. So here's a first one. Let's say you have this. What I want you to do is identify that this does have the structure to be a trinomial square, and then I want you to factor it. So 16x squared minus 56x plus 49. First thing I want you to do is identify, is this a trinomial square? Does it meet the structure? So 16x squared, 16 is 4 times 4. 49 is 7 times 7. So then what I told you, the shortcut is this. Is 4 times 7. 4 times 7 is 28. Is this half of my middle?
Yeah.
Yes. So it is a trinomial square. So you can use the shortcut. If you don't want to do the shortcut, then you do 16 times 49 and you mess around with the factors and find the ones that add up to 56. But here's my shortcut. And so you said 16 is 4 times 4, so that makes the first term 4x times 4x. 49 is 7 times 7, so that makes the last term 7. And they have to add up to a negative, so I put a negative in there. So 4x minus 7. One more trinomial square for you to take a stab at. 9y squared plus 60y plus 100. Once again, first, please identify that that is a trinomial square, and then go ahead and factor it. 9y squared, 9 is 3 times 3. 100 is 10 times 10. 3 times 10 is equal to 30. Is 30 half of this middle number? Again, it meets the structural criteria. So if you like that, then 3y times 3y, 10 times 10, they need to be a plus 60, so you put a plus there, and we're done. We're good to go. Questions about trinomial squares? So when you go to do your homework on section 5.3, okay, here's where we are. We've done all of 5.2. 5.3, we have done differences of squares and trinomial squares. So as you're doing the problems, anything labeled with a difference of squares or trinomial square, you can do. We have one more topic from section 5.3 to talk about, and we will do that next time. We're going to end with one final problem. We'll just pause the recording here.